Hello guys, welcome to my channel Brain Tech.
Today, we are going to see sums on general system of forces. Before we start with an example, the steps for solving the sums on general system of forces is such that we have already covered in a previous video, that is the problems on concurrent system of forces and problems on parallel system of forces. The link of the video is already given in the description box, so kindly see that. It will be easy for you to understand this sum. So let us start with an example. In this sum, they have asked determine the resultant of the force acting on point B and also locate position with respect to point B. What does it mean? Locate position with respect to point B means you have to find the distance with respect to point B. Now before we find the distance, you should know the value of resultant. So let us calculate the resultant first. The solution for this sum is such that to find the value of resultant you should note the value of summation f of x and summation f of y. Now to get the value of summation f of x and summation f of y, we'll see in the diagram. If there is an inclined force, first we'll resolve that. So here there is an inclined force of 50 Newton. So we'll resolve it into two components. Here angle is making with horizontal plane. So we'll make an alternate angle, and in the last video I said that angle making with the horizontal component or vertical component, that will be the cos component. So this is 50 cos 60, 50 sin 60. This is vertical force and that is an horizontal force, so no need to change. So first step is summation f of x. The sign convention we will be using is whatever goes towards right will be taken as positive. So 50 cos 60 is going towards right, then 100 Newton is vertical force, 120 is again a horizontal force, so that is going towards right. So your answer for a summation f of x when you will calculate will be something around like 145 Newton, and that is positive. So we'll show an arrow, that is it is towards right. Now to get the value of summation f of y, my sign convention will be whatever goes upward will be taken as positive. So let's see, here 50 sin 60 is going downward, so I'll write minus 50 sin 60, then it is minus 100, that's an horizontal force, won't account. So here when I calculate, I get the value something as minus 143.3 Newton, but I'll write only the magnitude. So it is 143.3 Newton, and this negative sign will compensate into direction, that is downwards. Now to get the value of resultant is summation f of x the whole square plus summation f of y the whole square. Now when you put the values, that is 145 the whole square plus in summation f of y just put the magnitude, which is 143.3 the whole square. Something comes out to be r is equals to 203.8 Newton. Now to find the direction theta, how to get it? To find theta, it is tan inverse summation f of y upon summation f of x. So put the value of summation f of y, which is 143.3, and summation f of x as 145. So you'll get something around like 44.66 degrees. That is theta equals to 44.66 degrees. After getting the value of direction theta, you need to plot resultant on your diagram. But they said that resultant should be with respect to point B. So resultant will be like somewhere around B, like to the right of B or to the left of B. But I don't know that it is to the right or to the left. So I'll just assume that my resultant is towards right of B. Now few of you will have confusion that why I have drawn a resultant in an inclined way. To understand that, you got the value of summation f of x something as positive and summation f of y as negative value. So with this, positive means towards right, negative means towards down. So your resultant is somewhere here. I have just taken the value of r from here and plotted somewhere around, like near to B. So to the right of B. So I think you have got cleared why I have plot resultant like that. So to find the value of D, I'll show that the value of D, it is always perpendicular distance to the force. So to find the value of D, we'll be using Varignon's theorem. So applying Varignon's theorem, moment about B resultant is summation of moment B for the remaining R into D. Now we'll see with respect to B you need to find R into D is what? Clock. Now let's go ahead with it. We'll just say what is the sign convention we'll be using. Whatever goes anti-clockwise we'll be taking as positive. So your R into D is negative because it is going clockwise. So remember this negative sign. Then we'll account for all forces. So which is 50 sine 60 into, with respect to B it is 40, and that is what? Anti-clockwise positive. Then here it is 50 cos 60 won't come because there is no perpendicular distance mentioned. Then it is 100 into 20, that is also anti-clockwise, so that is also positive. Then now 120 kilonewton is horizontal, but here perpendicular distance is not there, so you need to find it. So how we'll find it out? Just look here, this is one of the simplest geometry we'll be using. We'll draw the construction lines. Draw a right angle triangle. It is forming L. L means it is 90 degrees, so this is 30 and this is remaining is 60. How we'll get the value of x? So it is, can I say sine 60 is equals to opposite upon hypotenuse, that is x upon 40. So hypotenuse value is 40, so x is 40 sine 60. So value of x is 40 sine 60. I'll keep as it is. If you need to calculate the value, you can calculate and then you can put here. So now force is what? My again it is 120 into perpendicular distance is x. This is your perpendicular distance is x. X is what? 40 sine 60, and that is what? Again clockwise, so it is negative. Here R value you have it, so I'll write here it is negative. My R value something I got as 203.6 into distance D is unknown, and all values you have to copy down it. 50 sine 60 into 40 plus 100 into 20 minus 120 into 40 sine 60. When you calculate throughout in your calci, you will get the value something around like 2.08 centimeters, and that too positive. Positive means whatever assumption of R I took it, that is true. Means the resultant is acting towards right of B. So you have to mention it that my assumption is true because my value of D is positive. So we'll write as R equals to 203.6 Newton lies to the right of B. I hope that you have understood this example properly. If you have any query related to this sum, let me know in the comment section. Stay tuned for my future videos. Thank you.